Have you ever looked at a blade of grass and thought, hey, you might just save the global economy? Well, welcome to This Explainer. Today, we're unpacking the Ecological Engineering Manifesto. We are going to explore how microscopic biology, stuff you literally can't even see with the naked eye, can actually be engineered to drive massive, climate-resilient economic expansion. We're talking about completely rethinking how we value nature, moving away from vulnerable, above-ground forests and building an invisible, fireproof vault right beneath our feet. We've got a great roadmap for this explainer. We're going to breeze through the taxonomic blind spot holding us back, unlock the molecular truth with chloroplast genetics, secure that all-important subsurface carbon, and then scale it all up to massive economic expansion, capped off with the biostewardship dividend. Let's get right into it. Just a quick heads up before we really get into the weeds here. This manifesto we're unpacking, it's a science policy translation note. Think of it as a conceptual blueprint meant to bridge that massive, frustrating gap between advanced lab science and actual government action. The templates and numbers we'll talk about are demonstrative, really just there to spark serious dialogue among financial ministers and environmental agencies, not act as active legislation right this second. Okay, starting off with part one, the taxonomic blind spot and the foundational flaws in how we currently do conservation. So right now, we rely way too heavily on what plants just look like. But here's the problem. Extreme heat and drought literally distort how plants grow, creating these deceptive lookalikes. We end up with duplicative naming errors, which means governments are unknowingly misallocating millions in public green funds to protect the wrong plants. The manifesto flips this on its head with molecular truth. We're talking about genetic verification that is completely immune to the weather. It exposes a plant's true evolutionary survival traits. And this visual reliance creates what we call the missing capture in carbon accounting. Currently, international laws heavily over-reward visible above-ground wood, specifically your standard C3 forests. But think about it for a second. Why on earth would we put all our climate assets in a wooden vault that can burn down in an afternoon? We are dangerously concentrating global carbon assets entirely in highly vulnerable structures. Traditional tree planting just fails to secure long-term climate-proof carbon because one wildfire can send it all right back into the atmosphere. So how do we fix this? That brings us to our second stop, unlocking that molecular truth through genetics. Enter cpSSRs, or chloroplast microsatellites. Now, I know that sounds like a mouthful, but these are basically highly stable genetic barcodes. Because they mutate predictably and bypass those look-alike physical traits we just talked about, they act as a diagnostic filter. These markers literally prove which ancient plant lineages are naturally pre-adapted to survive extreme thermal and drought stress. It's mapping true evolutionary survival, plain and simple. The manifesto proposes deploying these through national bio-audits. Imagine giving local farmers and customs agents handheld genetic toolkits to track these cpSSRs right out in the field. By filtering out the fakes, state ministries can finally protect public funding. They can base their multi-million-dollar green budgets on hard, auditable genomic facts rather than wasting money on deceptive visual counts. Next up, part three. Let's look at how we take that genetic truth and use it to secure subsurface carbon in an invisible vault. The absolute key metric you need to know here is the subsurface carbon fraction, or SCF. This is the percentage of total ecosystem carbon pumped deep below the topsoil layer. Guys, this is the ultimate biological bank account. When you drive carbon deep underground, it becomes mathematically insulated from climate shocks and wildfires. It's locked away, safe and sound. But to get a high SCF, we have to rethink what we plant. Traditional C3 trees keep almost all their value above ground. High structural biomass, but a really low root-to-shoot ratio. They are sitting ducks for fire and drought. Now, compare that to C4 grasses. These things are biochemical powerhouses. C4 pathways fix carbon at absolute breakneck speeds and use massive vertical root networks to pump it safely out of harm's way. They survive extreme droughts that would literally instantly kill traditional trees. Now, to be clear, we aren't abandoning trees entirely. We're building botanical teams. This dynamic functional zonation table shows how you pair them up. In dry, arid zones, you anchor the soil with deep-rooting perennial C4 grasses like vetiver and provide canopy with heat-tolerant C3 trees like acacia. In temperate zones, you might pair miscanthus grass with broadleaf hardwoods. It's teamwork. It optimizes the landscape to capture carbon above ground and securely lock it below ground. All right, shifting gears to part four, multi-scale economic expansion, because we have to talk about how we actually finance this rollout. It leads to the million-dollar, or I guess billion-dollar question. How do we fund this high-tech rollout without completely draining public treasuries? Handing out decentralized, high-tech genetic toolkits to remote regions is not cheap. Taxpayers can't foot this bill alone, which means we need a fundamental, absolute shift in how we finance ecological infrastructure. The answer lies in blended public-private partnerships. Basically, the state provides a safety net with sovereign guarantees and anchor grants to lower the risk. Then, private investors bring the upfront cash, buying sovereign resilience bonds to fund those rural toolkits. And how do the investors recoup their capital? Through the premium, fireproof subsurface carbon credits this whole system generates. It's brilliant because it completely de-risks the sovereign environmental ledger. It creates this incredible multi-scale enforcement loop. Step 1, global capital funds the localized tech. Step 2, rural districts and farmers deploy those C4 and C3 networks using the handheld scanners. Step 3, the soil matrices' deep root arrays secure the carbon. And step 4, that auditable data flows back up, stabilizing national GDP and unlocking premium global trade assets. It's a totally seamless closed-loop system connecting global finance directly to the soil. Which perfectly tees up our final section, Part 5, the Biostewardship Dividend. We absolutely cannot forget the human element here, because traditional conservation often turns local populations into economic casualties. Under this manifesto, there is a mandatory minimum rule. 40% of project funding must go straight to local and indigenous farmers as a monthly biostewardship dividend. This is huge. We're transforming them into compensated, high-tech stewards of these engineered zones, fully decoupling their household income from crazy, volatile crop markets. And it goes further. Local communities retain full intellectual property ownership. If a unique, climate-resilient plant strain is discovered on their lands, using these genetic toolkits, the community holds a mandatory 2.5% commercial royalty right on international seed sales. This legally and permanently puts an end to corporate biopiracy. No more stealing natural assets. When you bind public funding to strict performance-tied indicators like this, you instantly upgrade a nation's standing on the global stage. It cleans up database errors for life-on-land goals. It provides actual, auditable capture equations for climate action. And it protects agricultural yields from climate shocks to drive towards zero hunger. I love this quote from the manifesto because it really hits the nail on the head. We are finally, thankfully, moving away from pouring billions into rigid, decaying concrete like seawalls and artificial flood channels. Instead, this policy shifts that massive capital into smart, self-healing, data-driven biology that actually scales with the climate. The tools to verify genetic resilience and secure carbon safely underground, they exist right now. So the question is, will we keep betting the global economy on a forest that could literally burn down tomorrow, or will we finally lock our future in the invisible vault beneath our feet? Thanks for joining me on this explainer. I hope this totally changes how you look at the plants right outside your window.